Okay, number 54 in the summer skill set, sorry. If we multiply both sides by 4, we still get cosine of negative 3 theta equal to 0. 0 times 4 would be 0. 1/4 times 4 will be 1. 1 times cosine is cosine. So I want to figure out where the cosine is equal to 0. And then the negative 3 theta means that from 0 to 2 pi, instead of there being 2 locations, that cosine is equal to 0, there's going to be 3 times that many because you're going to do 3 cycles of the cosine curve from 0 to 2 pi. So if normally the cosine curve makes one full cycle between 0 and 2 pi, if I have a 3 theta, it's going to do 3 cycles in that space. Something like that. So we need to figure out those locations. You can use the unit circle. Think about where is cosine equal to 0. Cosine theta is equal to x over r. Comes from drawing a triangle in quadrant 1. X is the base, y is the height, r is the hypotenuse. So cosine theta at that angle is the adjacent over the hypotenuse, x over r. So where is that equal to 0? Any point on the unit circle has a radius equal to 1. So it's going to be a quadrantal angle. For example, this point right here is 1, 0. So x and r would both be 1. So cosine of 0 would be 1 over 1. Cosine pi over 2 is 0, 1. So the x is 0, the y value is 1, the r value is 1. So cosine theta is going to equal 0 divided by 1. So cosine theta equals 0 there. That also means that cosine theta is going to equal 0 at 3 pi over 2, because that's going to be at 0, -1. So cosine, or 0 divided by -1 is also 0. So at this point then, we take the inverse cosine of both sides. Inverse cosine of the cosine of negative 3 theta is negative 3 theta. Inverse cosine of 0 is pi over 2 and 3 pi over 2, or pi over 2 plus pi times n. So that's my general solution. So pi over 2 plus pi is 3 pi over 2, plus pi is 5 pi over 2. So now we're getting into coterminal angles. Anytime we're solving for a multiple angle, we're going to use the general solution. Then I get the theta by itself. So divide both sides by -3. And theta will equal negative pi over 6 minus pi over 3n. Or, that's the general solution. Theta will equal negative pi over 6 minus 2 pi over 6 times n. I like to keep my second part of that expression into the same denominator as the first part. It makes it easier to go when I need to come up with all the answers. Okay, then you just let n equal different numbers. If I let n equal 1, 2, 3, 4, and 5, I'm just going to get more and more negative, and I do want the answer to be between 0 and +2. So we're going to let n equal -1, -2, -3, -4, -5, and -6. The reason I'm going to do all of those, I know already that there's going to be 6 answers. I know that from 0 to 2 pi, cosine theta is equal to 0 twice, pi over 2 and 3 pi over 2. Because of the 3 times theta, my period is 1/3 of 2 pi, or 2/3 pi. So there's going to be 3 times as many solutions. So 3 times the 2 solutions gives me 6 solutions. So I'm going to let n equal all those values and start plugging stuff in. So theta is going to equal negative pi over 6 minus 2 pi over 6 times -1 and then times -2. And then times -3. Etc. So negative pi over 6 plus, go back to this one, negative pi over 6 plus 2 pi over 6 is pi over 6. And then really I'm just going up by 2 pi over 6 each time. So the next one should be 3 and then 5. We can double check that on the second one. Negative pi over 6 plus 4 pi over 6 is 3 pi over 6. The next one's going to be negative pi over 6 plus 6 pi over 6, so 5 pi over 6. So I am just going up by 2 pi over 6. So do that until I get all 6 answers. 9 pi over 6, 11 pi over 6. And those are my solutions.